his prime area of working is in data, big data, data analysis, data science. So I think his inputs will be valuable to you. Sir, over to you.
Thanks, Dr. Ranjana. Good afternoon to all the participants. It's my pleasure uh, being here and talking to you. So let's start uh, the talk. One modification in the introduction is that I have handed over my head of the department charge to my next in command. So uh, my tenure as head of the department, computer science engineering, is over, and rest is as a professor in computer science and engineering department. So, as per my mandate today is talking about data pre-processing, right? So, I think you are introduced with the notion of data. The notion of data is itself very important. That you are a big producer of data all the time, and you are a big consumer of the data, every one of us. So basically, from consumer to prosumer, so we are producer as well as consumer both. And whatever uh, miracles you can call them, I call them because 25 years down the line, uh, it was a dream, what we are realizing today. And what we wish to realize is again seems very near, but it may take time. Like you must have noticing the wonders of artificial intelligence backed by the growth in data that is happening. Artificial intelligence is not new. It was coined nearly in the fifth decade, in 1950s. It came actually. And since then, there were very small successes in application of this and building a machine which is intelligent, which can learn on its own. But now there are machines which can understand you, which can listen to you, talk to you, answer to your queries, right? I'm telling you all this because the basis behind the reason why after 50 years, 60 years, 60 odd years, this success has kick-started. And we are all into it. We are all living in that world. And that is because of the data. So the compute is now data-driven. Although with the volume of data we are facing today, and with other characteristics of data, which we call them big data as 5 Vs, right? Whether it is volume, variety, veracity, and all other characteristics like that. So let's not go into it. So this data itself is such a gold mine, and
Good afternoon, Prerna.
this data itself is a problem to tackle with because of these characteristics and because of its volume itself. All right. So the traditional approaches to tackle this huge volume of data coming with heterogeneous sources, coming with huge speed in data streams. It offers great challenges actually, right? When it offers great challenges, simultaneously it has presented lots of opportunities. Challenges in terms of storage, challenges in terms of analysis. On the contrary, you have got lots of opportunities. And by exploiting some of those opportunities, we are enjoying the wonders which AI together with ML and cloud and big data is offering to you. So presently we are in the fourth industrial revolution. Most of us may not have seen previous three industrial revolution. But
second part है वो सिर्फ 5000 records पे कर ले, पूरे 17 पे ना करे.
Ranjana ma'am,
there is some disturbance in
the administrator can the owner can mute all the participants. So it would be better.
Yeah, please carry on, sir. They all are muted.
Right. So the data-driven compute is making wonders. So when everything is data is behind everything, you can say, right? Even when you have chosen this FDP to be attended, you must have collected some data. Whatever small steps you take in your daily life, right? You do observe, and your observations are facts, are termed as data. You look at a person, collect certain data, lot of data, and then decide whether to be friends with or whether not to be friends with, whether to talk or whether not to talk. So that's a decision which we normally take on our observation. And that should be. But when the data is huge and the data is heterogeneous, right now the applications are also very complex. Producing complex data. It's not simple text data or it is a structured data, not even semi-structured data, right? People are resorting to new data models like graph data models to harness the potential which is there inside the data itself. I still am getting some background noise. If we can stop that, I think participants would be happy. So, Mr. Janardhan. Okay, that's great. So, what I was talking about is understanding data. So, now since you have understood that there is huge data and data is important, so before making meaning from the data, we need to understand that data, right? Understanding that data requires what? Requires a model, which you call data model traditionally, right? So representing that data at a certain level of abstraction, in order to understand that data. Donald Knuth, one of the pioneering computer professional, has very rightly said that a computer professional would only succeed if he can traverse multiple levels of abstraction simultaneously. So you can have your understanding at different levels of abstraction of the data. So data model is important to understand the data. You decide the data model. You model your data with the tools that data model provide. If you are using relational model, as simple as that, which all of you have done. So you model your data in relations, right? Whether it is a relationship you are capturing, or you are talking about entity, or you are talking about the constraints, everything comes in the relation, because that's the only notion in relational model, right? You're talking about XML model, you model your data like that so that understanding can be there and you can understand that data. So there are lots of data model. We are not going to talk about different data models, just an elaboration that in order to understand the data, you need a data model. And it's not, I'm talking when I'm saying that you need a data model, that you need a data schema, right? Because now we are having data repositories and call them databases, which do not require a schema or predefined schema, you can say, because the data is such that you cannot put them in a predefined schema. That's why they were invented, which is called popularly known as NoSQL databases. Okay, so in order to serve different needs, they were developed. So you got the data, you put them in data model. Now there's a task to analyze that data, all right? And this we are talking in terms of a static data only. The data could be very dynamic. I mean, the data could be in terms of data streams, right? So there are altogether different platforms or frameworks has been developed which addresses the challenge of tackling the data streams, right? So it's all in open source available. Apache is a good name to reckon with, where we have got lots of technologies being developed for big data computing. Right. So storage, modeling, and then analytics. Let's understand like this. All right. So before deploying analytics, which you would be learning, that I started with how to tame big data. Right. When it is big, you know that when the problem is big, the monster is big, you have to divide it. And that's how the divide and conquer developed, right? You have to divide the problem into smaller problems and give those smaller problems to different workers. Now, if all of you, if you can recap your experience when you divided a bigger problem into smaller sub-problems and given to different workers, what challenges you faced with? Because they are doing, each worker is doing independently, right? It's not dependent. So if the workers are doing independently towards the same goal, establishing synchronization, they might have their own different clocks. Even establishing synchronization of clock become a challenge. So we have got some servers which do this job when we establish cluster, and many challenges are there. But the initial and the foremost solution which came in the mind is divide the problem and get it done. Since there is deadlock, there is synchronization, there is use of semaphores, and the developer need to be concerned about this distribution of task and collection of the responses. And that's huge. That we ask from a developer, right? So what is then required was to provide a compute engine to the developer at a higher abstraction level, which frees the coder from the details. So again, now I'm talking about a level of abstraction up, right? And that compute engine were initially came from Google as patented MapReduce. Then it was later on developed as open source by Hadoop MapReduce, along with Apache, right? For a long time, Apache Hadoop MapReduce served the purpose to distribute the job among the workers and get it done at a higher level of abstraction. So the coder needs to worry about the map task and the reduce task. So every task which can be computed with a mapping task and the reducing task, that is dividing the task into workers and getting the responses aggregated, all can be done on Hadoop in a distributed fashion. And rest of the complexities which we were talking initially were tackled by the framework itself. But Hadoop again had certain limitation, like it doesn't support iterative nature of jobs, which sometimes our algorithms are, because Hadoop is writing, MapReduce is writing and reading from a shared storage, which we need a distributed file system, which is popularly is Hadoop distributed file system, because the job is being done in a distributed fashion, right? So when a node is writing, when a worker is taking data to process from the HDFS, that is shared storage, which is nothing but a disk, obviously, shared across the machines, right? Or it could be different disk storages, local disk storages, which with the nodes, and you create a logical shared storage, which is exactly the case. So reading data from the disk and writing data to the disk, all the intermediate values, it is going to take time because IO is costly. Right? It doesn't support in-memory computation. Then came the next version of it, or another project by Apache, that is Apache Spark, right? So which has been a top-notch project for a long time till even 2016. Development of Apache Spark as a unified framework for supporting different applications. So there are huge libraries available to process the data in a distributed fashion, stored in a distributed storage, and all the types of libraries are available, whether you are doing it in SQL type operation, so you have got a Spark SQL, whether you are doing it in for machine learning, so you have got ML or MLib, Spark ML or Spark MLib, or you can have recently being developed, which is in nascent stages, that is called a library for graph databases, it is GraphX. So I would recommend and suggest you to go for a Spark as a compute engine, which supports Java, which supports R, which supports Python. So that is why we are calling it as a unified one. It is optimized due to lazy evaluation. We are not going to talk about lazy evaluation. If there's a question later on, we can answer that. So it is optimized and it addresses the challenges, shortcomings of the Hadoop MapReduce, as well as it provides you the tools that are required to tackle the monster which you are struggling with, that is big data. That was one story. The other story goes that once you have got data and before processing that data, right, And since the data is, how do we collect the data, right? We observe it, or there are a lot of sensors which we deploy, right? So it is, you can say, instrumentation, engineering or instrumentation advancements which makes this data collection feasible. Whether you are collecting through sensors, whether you are collecting through software operations, right? The software itself is collecting the data. You are doing some transactions, you are doing even web surfing, which you do most of the time, and you would be surprised who are not working in the area of weblogs. So the data which the user by its mere usage is produced is huge. It's even larger than the actual web data itself, right? So these logs are being recorded at many places, at your own machine, at the proxy level, at the service provider level, at different other levels, right? In between. That is nothing but a usage log, how it is being used. So which page is being requested by this person, or followed by which page, followed by which page, followed by which page for each web server. Right. So when we collect this data, by any means, there are certain problems which needs to be tackled before being processed, right? Maybe a notion of meshing data, maybe a notion of some other notion, right? Which would be talking about as per our mandate. So it was just a recap to bring you to the notion of data pre-processing, because the way we are going to collect the data would bring inconsistencies in the data itself, number one. The way you represent the data, that is not our concern today. And that representation is very important. Even if you clean the data, improve the quality of the data, still that representation is going to decide that which algorithm is the best suited for this representation, right? So let me share some, because data pre-processing is a very basic thing. Most of you must have already gone through this, those who are interested in this domain, right? Those who are working in, especially in data mining area, that what do we mean by data pre-processing? So just a minute, I will share my slide.
Anil, I would like to mention one thing, that this is a mixed of participants. So there are few participants who are from non-IT background also.
Okay, no problem, no problem. That's fine, that's fine. I'll take care of that. So if there is question by now, any confusion with the participants, so let's address that before.
Yeah, I have one question, because as she rightly mentioned that I'm not a computer professional, I'm from the finance function really. So some of the programs you mentioned, like Apache, Hadoop, what are these? If you can explain a little more about that.
Apache is not a program; it's a company which normally tackles about lot of different applications or softwares which are commercially available as well as in open source market. So Hadoop is a compute engine, like I'm talking about that more advanced version, that was Spark as a compute engine. So initially I started with that your data is big, right?
Right.
So you cannot, let's say you have got a 3 GB or 4 GB memory in the RAM, and you need to process a 1 terabyte data file, and you just want to sort it, right? That's a
Right.
very simple thing. Before doing some filtering or running query on that file, you need to sort that file, right? Data file.
Right.
So there would be limitations when you are doing it on your machine. You are not doing any data mining. You are not doing anything. You just simply want to sort that file.
Okay.
You will find that you are limited with the resources, with the constraints that your machine is having, right? It's a 4 GB or 8 GB RAM. You cannot fit 1 terabyte of file in this. So you need to resort to algorithms which allows you to do disk-based sorting rather than in-memory sorting algorithms, number one. And again, further, you would be restricted to the disk speeds, the read-write speeds of the disk, and transfer of data from disk to main memory and from main memory to disk back.
Okay.
So it's going to take even weeks to do that. Now, what we started with is that you can divide this 1 terabyte file into, let's say, 20 chunks or 100 chunks and give 100 workers, 100 small workers. You don't need big machines. These are commodity machines which are available, and you can create a cluster of those machines, and you can divide this task among them and get it done. So the division and the accumulation of the result requires lot of low-level details actually, right?
Okay.
So to avoid a programmer going into such details, there was a need to have compute done at a higher abstraction level.
Okay.
Abstraction level you can think of in the sense that when you instruct someone procedurally, you are telling details, like even you need a cup of tea, and you may say that someone go there, do this, then do this, then do this, then add sugar, and then bring that cup to me, right? Or you can simply say to a trained man who normally serves tea to you, or who knows how to serve the tea, you can simply say, get me a cup of tea. Right. So get me a cup of tea is a non-procedural way of saying, which is a higher level of abstraction, whereas the other way, which we do in the programming languages like C or some other languages, that is a procedural way of doing it. Right. So non-procedural way is at higher level of abstraction. Likewise, we needed compute engines which take your task at a higher level, right?
Okay.
So that was Hadoop MapReduce initially, right?
All right.
So based on Hadoop distributed file system, because you need a file storage as well, which is distributed file storage, which is not in one machine, because 300 terabytes data file you cannot store at one machine, right? So if Google is processing, let's say, petabytes of data every 24 hours, so obviously petabytes of data, petabyte is a huge number. Now the compute is XI scale actually, right? So you cannot do it at one machine or two machine or three machine. You need thousands and hundreds and thousands of machines joined together to process such type of data, right? So how to do that? That was the challenge. Just to introduce it, because the FDP went with the data sciences, and there are a lot of things to talk. So I just wanted to tell the audience regarding the big data monster and the technologies that attempts to tame that challenge, right?
Right. Thank you very much.
Okay.
It's clear.
So let's come to the task where we have got the data, we have collected the data, whether from a single source or multiple sources, right? Before modeling the data, we attempt to pre-process the data. right? Because the data might be having lots of inconsistencies. In order to improve the quality of data, all right? So, simple example I gave you, just simple that there might be missing values in the data, right? So, how to tackle missing values in the data, right? So, as a step, as an important step before doing this data analytics, we do this data pre-processing. As a case study, you can think of like you are analyzing tweets, right? Twitterati is a medium which is producing a data stream at a huge velocity, right? Nearly 6,000 tweets per second, right? So, and if you are analyzing large number of tweets and you know that because it is a user generated content, right? So thanks may be written as THX or
The background.
Okay.
Yeah.
So, what I was talking about is data pre-processing.
Yeah, pre-processing of data.
Twitter analysis, right.
Yeah.
So we have got tweets where the user might be using because the user generated content, and user generated content is in the terms like I can write thanks as THANK or THX or something, which may be understood, which may not be understood by the receiver. So in order to make meaning out of it, right? Or it could be in different languages, it could be missing words, it could be broken grammar or incorrect grammar. So making meaning from the collected text as a collection of tweets, and let's say we have the task of summarizing the tweets. So we need to process those tweets, right? So removing the words which are not making sense to the process or to the software which is trying to analyze that. So that's another case study of data pre-processing itself.
Right.
So let's go into the steps of data pre-processing. Why process the data? In order to improve upon accuracy, in order to bring the completeness, right? The data is not recorded, data is unavailable, because presence of null value, even in relational databases, when we talk about, like we have got a tabular structure of data, and one record or one row of that table represents the record of one employee. Fine.
Correct.
And the phone number column is missing, right?
Right.
So what does it semantically means actually? Null value has got different semantics. It can be that the value is not known, or the value is not present. Not present and not known has got different semantics altogether. Right. If it is not present, means he doesn't have phone. If it is not recorded, means he has phone, but it is not recorded. So we have got different way of treating that semantics. So bringing completeness to the data for missing values, improving upon the consistency of the data, right? When we say that when we have got a pointer to which is pointing to some data and that data is not there, right? We say go to the room number 5 and get this, and there is no room number 5, right? So we know that we are pointing towards something which is not existing, so it is dangling, right? So likewise, different dimensions which are required to be improved in order to by the data processing itself, right? So let's talk about data cleaning, which involves fill in the missing values, smoothing the noisy data. Outliers are again a problem, right? You know, even if you simply take an average of the marks.
Excuse me, sir.
Hanji.
Kindly put your presentation in slideshow mode.
It's in slideshow mode, I think.
No, sir, it's
okay.
Not.
Let me do it again. Is it now?
It's not in full screen, sir.
Okay.
No, it's actually not in slideshow mode.
Actually,
I have edit mode actually.
Just a minute. At my screen, it was in
Okay.
the screen mode. Let me do it again.
So start from the first slide, sir.
Okay, that was the first slide. That was the first slide. Is it still in edit mode?
In divided screen.
It is actually showing slide layout on the right hand side.
Okay.
Okay.
It's in splitted mode.
But even if I am playing it,
if you, I mean, the zoom is 145%. Maybe because of that one.
That I'll do. Let me just wait.
You can just press F5. Press F5 key.
It's not actually PowerPoint presentation. That is why it is creating.
Yes.
Yeah.
It's a keynote presentation. So
sir, you can just press play button on the top of the screen.
I've played the play button. It is
press on the format button. Press on the format button on the top right.
Okay.
That's right.
Yes. That's good, sir.
But still, it is not in play full screen mode. If it is okay, we can go ahead.
Yes, it's okay, sir.
I think it is okay. With should be all right.
No problem. That's fine.
Okay, thank you, sir.
Right, great.
All right.
So, major task in data processing involves cleaning of data, and integration of the data reduction, data transformation if required. We would be talking them in detail. Simply that cleaning, we simply take an example of removing outliers, because you know that even if you are taking simply an average of marks or an average of anything inside your class or anywhere, you know that if somebody has got 98 marks and rest of the students are below 70, so the central tendency represented by the data is modified actually, right, by the presence of these outliers. So that's how the average, like mean, as a measure of central tendency, is susceptible to outliers. We talk it, right? So if we can remove outliers and compute central tendency, it's better representing the central tendency of the data as compared to in the presence of outliers, right? Noisy data removal is very important, because if we know that which is noise and which is data, then it is very good. But unfortunately, most of the time, we cannot distinguish. It's very difficult to distinguish. Whatever we are talking noisy, whatever is noise for you may be interesting for me, actually. All right. So that way, it's difficult to identify noise, but still there are approaches which allows to separate noise from the actual data, right? And the integration of the data is required because the data is coming from different heterogeneous sources most of the time, and we need to get it integrated, right? So if there are 4 gates and the entry at each gate is recorded separately, and we need to get all the members who have entered the institute, we need to integrate that data. Likewise, a simple example of file. If there are 4 campuses, like MIT is a big university, so you may be integrating the individual databases of maintained at their own places, and that integration itself is again a challenge, right? It's a challenge on a schema. It's a challenge on understanding the semantics developed, unless and until it's exactly similar data files or databases. Schema integration would be a problem. That is why you can ask this question later on. So why is this a schema integration is a challenge, right? Data reduction is often required because data size is huge, and if we need to compute it on a smaller machine and at a smaller scale, we sometimes resort to reducing the size of the data in terms of dimensionality. In terms of,
sir?
Yes, please.
Sir, I have a question.
Mm-hmm.
So in this generation, like almost each and every word, like they are having short forms or slangs and all. So all that will be also considered as a noise. Like, will that be removed out of the actual data?
No, it depends actually. It depends on the application you are working with, right? When we are writing, let's say, small messages, or we are producing blogs and writing slangs in it, and somebody is trying to find out spam blogs versus non-spam blogs, because blog, I presume you are aware with that is you produce some technical content.
Yes, sir.
And publish it, right? So it may be non-technical content as well. There are a lot of blogs which are non-technical. So if we are trying to process those blogs, filtering out spam and non-spam, we might be encountering this problem, right? So that to label a spam, to blog as a spam or non-spam, we need to understand the meaning, what it attempting to say, and unless and until, because to make the meaning out of it, we need a dictionary. We need to disambiguate, because one word might be having different senses as per the context, right? When we simply using apple, maybe using many different senses, right? We are using Java, again, many different senses, right? So making meaning for the context is nothing but disambiguating the meaning of that, right? So there's a lot of work in disambiguation. So, and that is, we require a dictionary for that, right? To make meaning out of it. So if we incorporate those slangs in a dictionary somehow, we can use it. We can keep them. And if the dictionary which we are using cannot make sense out of that, so obviously it's a noise for us. So it depends on how we are going to analyze it. It may not be noise for you because you are individually able to read that, right? The machine or the process or the agent, software agent, which is reading that blog, and then trying to label it as spam, non-spam, has a background dictionary, not like you as a experience, right? So over the period of time, that is what this machine learning is coming up. New words are coming up, being encountered by the same digital assistant. So it might enrich its own dictionary over a period of time with the different meanings of the slangs which you are using, right? And then the disambiguation can be applied. Okay. So at times it may be noise, at times it may not be noise. That is why I said that. And moreover, noise is interesting, right? For somebody, noise is interesting because noise may represent some interesting fact. Okay. So labeling a data noise or a non-noisy is always a challenge. Is always a challenge, right? I think I tried to answer your question. Okay.
Yes, sir.
Step further, and we can talk about data cleaning in a more detailed way. Right. So lots of potentially incorrect data. Maybe your instrument is faulty, maybe human or computer error, maybe transmission error. Right. So there could be something like missing data, which is very usual. In this present time of pandemic, I was called with the district administration and involved with the data analytics. The data which the doctor's team or the team, which you can call it a control center for the district, was collecting for the COVID patients, right? So, and then they were manually attempting to, you can say, that was, you can call it contact tracing, right? So with whom this person has been in contact since last 2-3 days, and then so that they can also be a certain administered that test, COVID test. So and there were a lot of incompleteness in the data, and there were the telephone numbers were written 9-digit only because it was collected on phone. Phone. Tell me your address. Tell me your phone number. Right. So when address and phone number and other details are being spoken over phone and somebody is recording, and while this transmission happens, and there are errors, right? So there were missing values and there were inconsistent values. भाई हमें मालूम है कि टेलीफोन नंबर जो है 10 डिजिट का होना चाहिए, 9 डिजिट का है, it is of use, no use, right? So it is inconsistent, right? Like you can take an example of, and it was very difficult to handle at that time, right? Because that was a serious data to work upon immediately in real time, right? So if you record salary as age as -10, let's say somebody's, right? So that's an error. That is not peaceful. That is not possible. So you can definitely term it as a noise, right? Because age as in negative or age as, let's say, for a person beyond certain limit, 150 or 200 or 500, again doesn't make sense, right? Inconsistency in terms of the values and the truth that the data object representing that value is inconsistent, right? At one place, the rating is rated in 1, 2, 3. At other place, the rating is at ABC. Meaning cannot be made out of it, right? Or it could be intentional as well. So data is not always available. That's how it get missed. It may be equipment malfunction, as I told. It may be inconsistent with recorded data due to misunderstanding. Certain data may not be considered important at the time of entry. Right. So missing data need to be inferred in order to complete the data. So that is the characteristics of data, that is the one quality characteristics of data, that is completeness, right? So improving upon that characteristics of data is what this missing data inference is going to handle, right? So how to handle it? The simplest solution is ignore the tuple. Just patient का phone number नहीं आया, उसको phone नहीं करेंगे. उसको phone नहीं करेंगे. If you do not phone that fellow in times of COVID, so it's going to spread to 10 more people, right? So sometimes it is not possible. You have to, and you cannot do inference for the phone. You are helpless. But sometimes you have got the liberty, you can ignore the record, that's all. If the record is incomplete, just ignore it, right? Fill in the missing values manually. It's tedious, infeasible. If you have got 9 digits, it starts with 9 and something, presuming that last digit is missing, you can dial all the 10 combinations possible from 0 to 1. ठीक है, 9 digit था, आखिर में हमने 0 लगाया, 1 लगाया, 2 लगाया, डायल किया, लग गया तो ठीक है. That is only 10 combinations we are trying, which is tedious. It's infeasible if we attempt at all the places to fill in and get that value. So we might be making 10 to the power 9 calls, right? Which is not possible. Or you can have automatically filled with some default value, which normally we do while writing code, right? So if this, when we're writing case or doing something, all of you have got a document separator which you adopt as per trained model in your brain. कोई document आपके पास आता है, you put it in this file and then you put other document in other file, third document in some other file, and there are documents which you do not know that in which file it will go, so you have got a miscellaneous file, right? उसको miscellaneous file में डाल देते हैं. So that is nothing but default, right? So or you can have some meaning to make inferences. So it could be Bayesian formula or some other decision tree or some other meaning where we can make inferences and predict, right, regarding that value. Noisy data, we talked about a lot. It could be faulty data collection instruments, data entry problems, data transmission problems, technology limitation, or inconsistency in naming convention. Handling has many ways to do it, right? You can do binning. Binning is dividing the data into smaller parts, right, in order to make more meaning out of it, right? So simplest binning is on frequency basis. So it is called frequency bins. First sort data and partition into bins, right? So equal frequency bins. नहीं अभी क्लास चल रही है, अभी 5 मिनट में, हाँ 4 बजे के बाद, हाँ कुछ बोलेंगे नहीं तो देख सकते हैं, ठीक है. First sort data and partition into equal frequency bins, then one can smooth by bin means, right? So that's a way you can try to handle it, right? So bin means can be obtained, or you can do median as another measure of central tendency, you can smooth by bin median or smooth by bin boundaries, right? In order to predict, right, for the value, you can have regression analysis, so smooth by fitting the data into regression functions, right? So all of you must have done curve fitting function. So if you can fit two-dimensional data into something like y is equal to fx or mx y is equal to mx plus c. So knowing m and c, you can find out y value with the help of x values, right? You might be sorted to clustering as a technique where we try to group the data objects which are similar in one groups and separate the data objects which are dissimilar. So within the cluster, the data items are similar, and across the clusters, the data items are dissimilar. That's how we try to group it. And then we detect and remove outliers, right? Or you can have human intervention, and or you can have a trained machine which can do this once the data is submitted to the process which is running on a certain machine, right? Clustering we always resort to. It's not a new term to even those who are not from this IT background.
I'm sorry, sir, but I believe your presentation is not moving.
Okay, I'm sorry again. So you must have told me earlier. It is so. Okay. Is it moving now?
Yes, sir.
So I was talking about binning. So handling data analysis, binning, regression, clustering, combined computer and human inspection. It could be, yes, I was explaining clustering. So all of us do clustering at some point of time. You enter a room and even if you don't have any experience in handling the objects which are there inside the room, say for example, one illiterate man entered the room with lots of books, lots of different varieties of books, right? The way the literate man will handle it's different, right? It will try to classify. But for illiterate men, if you ask that fellow to group those books together, right, to arrange the books, what it will do is that it will try to group the books with the similar nature, right, in terms of let's say shape, or in terms of hardbound or softbound. So finally, it would be turning out something like the magazines would be stacked together, and the newspapers, because of its peculiar shape, it will collect the data about the shape, length and breadth, and the type and the texture and whatever it is, unknowingly that it is a newspaper, right? It will stack the newspaper at one place and novels at another place of same size, and depending upon size, let's say, or depending upon bounds, depending upon this, the groups of books would be created. And they are nothing but clusters, because across the groups, they would be having different characteristics, and within the groups, they would be having similar characteristics, right? And then you can use this group to detect and remove the outliers, right? So if inside a bundle or a group of novels, you have got a magazine sitting there of different size, immediately it is a distraction to the eye, and you bring it out and put it in that magazine rack, right? Data discrepancy detection, you can use metadata. Metadata is, you can talk it as some description of the data itself, all right? Popularly, we call it as a data about data, all right? So that data which is used to define the data. Right? So when we say, let's say, x is an integer, right? So x is an integer means x takes a value from the integer domain, right? So, or the range of values for this type of data, because binding a variable with a data type immediately means that we are binding this variable to assume a value from this particular range, right? We can use commercial tools, data scrubbing, data auditing के तमाम सारे tools हैं, वो use किए जा सकते हैं. Data integration or migration.
So can we move to the next slide?
Okay.
Your slide is again not moving. No, it's not moving actually. You are in binning only now.
Okay, okay.
Now it is there.
Okay, coming to data integration, it combines data from multiple sources into a coherent store, right? As an example, I talked about multiple campuses has got different data stores, and if we are into the process of creating a data warehouse that is getting historical data from all the different campuses and storing it together for decision making. So we need to understand the schema semantics at one place and the schema semantics at another place. The simple example which you can take to understand this notion is that even the student is modeled at campus 1 and the same student is modeled at campus 2 with the characteristics, let's say, with the same characteristics. So the data object, the entity is same, and the type of attributes are also same. The name of the attributes are also same, let's say. But still the meaning might be different, because the meaning with which I put this attribute is semantically known to me, and the other person is having different sense of this keyword. Moreover, if we record name, age, somewhere we call it registration number, somewhere we call it, let's say, enrollment number, somewhere we call it student ID or security number. Semantically, they mean same. So when we try to integrate it, we need to tell the wrapper code that, well, though the name could be like this, but semantically they have got the same meaning. Or though the name is different, though the name is same, but they have got different meaning, right? Even if like that. So both the type of possibilities are there, all right? So in order to merge the data, the semantics needs to be merged first, understood first by the integrator to integrate the data from the two sources, right? So that's a problem with the schema integration, and that's how the notion of, or the idea of XML came actually, right? As a markup language, right? So that the data carries its own semantics with it. When you transfer, when you as a language of information interchange, it was developed actually. So when information needs to be interchanged across the machines, across the processes, across the databases, right? So what was the intended meaning of this data? That had to be carried with the data itself. Right? And that was what exactly the XML do, right? With the help of XML tags, right? Or because it is a tag based one, and we can follow the standard namespaces technique by which we know that these tags have got the meaning of these tags are defined in this dictionary or in this namespace. Let's not get into the notion of namespace, but it's a dictionary, you can call it, where the meaning of those tags, XML tags, which with which the data is being transferred, is defined. Detecting and resolving data value conflicts. For the same real world entity, attribute values from different sources could be different. Possible reasons, as I just discussed with examples, different representations, it could be different scales, right? Height record किया है आपने, कहीं पे feet में है, कहीं पे inches में है, कहीं पे centimeters में है. So you cannot simply integrate, right? The height in inches cannot come in foot in the same column because the range or the type of representing in that column by the column head, which we call attribute, that is called height, वो सेंटीमीटर में है. तो 160 सेंटीमीटर आया, 170 सेंटीमीटर आया, दूसरी तरफ 6 फीट आया, तो 6 फीट नहीं लिखा होगा, 6 लिखा होगा, right? It is 6, and you cannot write 6 under the centimeter because 6 centimeter height doesn't make sense, right? So lots of possible reasons which makes okay. I think it will remain problem.
Sir, sorry to interrupt you, but your slides is not visible, sir.
My slides must be visible. It's handling redundancy in data integration नहीं आ रहा है?
No, sir.
आ रहा है, ma'am. I think it could be some problem at your end. Because even I can see it. So maybe it could be some problem at your end. Other participants, can you see it or not?
I can see that.
Are able to see the slide?
Yes, sir. Yes, sir. I can see.
All right. So, ma'am, probably this is just a temporary problem at your end. Just refresh and probably it will come.
Okay, ma'am. Thank you.
Okay. There might be redundant data that occur often when integration of multiple databases, right? There's a notion of derived attribute, as we know. So one attribute may be derived attribute in another table, like annual revenue or gross, right? Expenditure or whatever it is, right? Which is computed from the stored records. Redundant attributes may be able to be detected by correlation analysis and covariance analysis. Let's go to that. Correlation analysis is important where we try to find out how dependent a variable or an attribute is on the other. We have got some relation. That how the other behaves when one value changes. Right? So for doing this, we can resort to chi-square test. There's nothing but based on chi-square statistic. All right. On values and values, and we can compute this chi-square statistic for any such event variables, right? So number of hospitals, let's say, is one variable, and the number of car theft in a city indifferent, and we are trying to find it out, right? And we can find the correlation between them, if any, right? Or the relationship, their relationship with some other attribute. When do we need chi-square test? When we are talking about trying to find out how A and B, how the two variables are related, right? Grades of math and the grades of science, are they related, right? एक सब्जेक्ट में जो आपके ग्रेड्स हैं और दूसरे सब्जेक्ट में जो ग्रेड हैं उनके बीच में रिलेशनशिप हम पता कर सकते हैं कि मैथ्स के बढ़ गए तो साइंस के घट गए, या मैथ्स के घट गए तो साइंस के बढ़ गए, ठीक है ना? That's how we run the chi-square test. As let's not get into learning about the how chi-square statistics is computed and looking at the test table. So that's observed value and that's estimated value. OIJ minus EIJ whole square upon EIJ, summation over I and J, we can compute this chi-square test, right? And with the degrees of freedom, with different degrees of freedom, we can look at the table and find out the correlation, all right? Okay. Break. 1 minute. I need to sign an important paper. I'm sorry. So. पांच कॉपी बनाई, आज सबमिट कर दोगे 15th, है ना? साथ कर लीजिए आज आप लोगों को ढेर सारी बताइए. ये ऑफिस में निकलवाएं, कहीं बाहर से निकलवाएं? बढ़िया बना दी लड़के.
Thank you, sir.
Okay, thank you. Okay. Okay, well, there was important work to do. Fine. This slide represents a visual evaluation of the correlation coefficients between the two variables on x-axis and y-axis, right? So as Pearson coefficient, this correlation coefficient varies from -1 to +1. So you can you can see that somewhere at zero correlation, you can see that this is a zero correlation, which shows that there is no correlation at all. You cannot interpret that how x and y are related. And this is a negative correlation completely, and this is a positive correlation. That is correlation coefficient 1, which indicates that well, A and B are related with this value. All right. Covariance is another way of preprocessing the data, where we compute covariance between A and B, and a positive covariance indicates that A and B both larger than their expected values, and negative covariance A is larger than its expected value and B is likely to be smaller than its expected value. And we have got independence between A and B when the two variables under consideration, covariance AB is 0. We can say that it is that they are independent, right? This is an example of computing covariance. We can skip this. We are running out of time. Okay, let's go to another strategy of data pre-processing where we address reduction of data. Right? Reduction of data. When we did not have enough storage medium or enough compute medium, and we have to process the data, we resort to this technique, right? So we obtain a reduced representation of the data set that is much smaller in volume. लेकिन ध्यान ये रखना है कि the data is reduced in size, but the analysis on the reduced size represents the analysis on the original size, which you call it population. So if you can do analysis on a sample, rightly selected, and your sample observation fits to the population, then your job is done. Right. So because you may have got terabytes of data and you cannot, with 400 megabytes per second read speed, reading 1 terabyte of file would need days, right? So data reduction strategies involves dimensionality reduction. Dimensionality is the different dimensions of data, means different characteristics of data, you can say, right? If we are handling, if you are talking about student record, the way you have modeled the student actually. And that's the limitation of your model, right? So if, normally we model the student in relational database as name, age, registration number, date of birth, phone number, the department, the course in which he's in, the courses in which he or she is enrolled, and so on. Right. So now if we are trying whether the student is going to pass or whether the student is going to fail in this end semester examination, whether the student is going to get a job after in the pre-placement, in the placement, or whether not, right? So when we analyze the data related to the student, we find that there are data related to dimensions which are not relevant for this analysis. Maybe relevant for some other analysis, right? But not relevant for this analysis. So obviously, if we can find out that nowhere the height of the student is coming as is providing any relevance to its prediction that whether the student is going to pass this course or not, right? Or whether the student's mental condition is good or not, right? So if it is relevant, then it is okay. If it is not relevant, we'll reduce it. Removing unimportant attributes. One way of doing it is bringing your problem to a different dimension, to a different domain altogether. And that's again a notion of representation, right? The way you represent your problem in one domain, you take it to another domain, you will see that it has reduced in size, right? So from one domain to another, you can use wavelet transforms, or you can use Fourier transforms. So that brings your data to another dimension, representing in terms of frequencies, right? And then you are processing the data of that domain, right? I typically take an example of as a matter of representation, right? That maybe since all of you are faculty members and you are struggling with examination and organizing schedule of examination and all, right? So even if in any case you are asked to propose a schedule of examination for the entire university, what data you need actually, and then the whole of the database is given to you, right? So all the students enrolled in different courses with all the details, right? Who is teaching which course and which students are appearing in which course, the credits of the course, and all that, all right? You can represent this problem by modeling the data as a relational one, that student records, course records, or room records, right? So these are the, or you can represent as a text files. You can have a comma separated variable CSV export, right? So that's the representation of problem in one domain. The other representation, which I like, is that you can represent the same data in a graphical domain by simply modeling the course as a node, right? If you look a graph as a set of vertex and edges, and you model course as a node and add an edge between the course, if there is at least one student which is common in the two courses under consideration, means if there is a conflict in the course, because they cannot be scheduled together, the simplest schedule would be schedule one exam for one course every day, but that will take a month, right? So what you do is that there are 20 courses which are being examined in one day, right? Simultaneously. But the only take is that these 20 courses doesn't have a single student in common, right? So if you represent conflicting courses with an edge, you get a graph, that is a course conflict graph, representing all the conflicts among the courses, right? And that representation would require you, has reduced this data, the data type. Now you are not bothered about what the number of students or the number of courses or who is enrolled in which courses and who is teaching which course and lot of other information. The only thing you have got to process is the course conflicts. Processing that course conflict will get you a schedule. If you now it's a simple graph processing technique, all right, and it will get you a schedule in a very less time. So representing a problem in a different domain reduces the complexity, right? You can reduce the data itself, right? That is called numericity reduction by following regression or log linear models. You might be doing sampling as a simple example, or histogram binnings, right? Sampling, the usage of sampling you have always been looking at, right? So when you are looking at pre-polls, right? How those pre-polls arrives. Each one of the person who have polled is not part of that survey, right? only a sample. And if it is corrected, if it is correct, you know that the analysis is going to be correct. The only possibility is that the sample itself doesn't reflect the population, right? Data compression could be would also be a prospective to reduce the size. If you simply try to represent a data in 2 dimension and same data in n dimension, you will find the notion of distance among the attributes goes away actually, right? Higher the dimensions are, the lower is the notion, the understanding of the computing the distance between them. It will be too sparse. Although as a human being, we are not able to understand or visualize more than 3 dimensions, but your data could be multiple dimensions, n dimensions, right? And could be a large number. That's why it is the density and distance between the points which is critical to clustering. क्योंकि clustering के लिए आपको distance निकालना होगा. दो objects जो similar हैं उनके बीच में distance कम होगा और जो dissimilar हैं उनके बीच में distance ज़्यादा होगा, right? So that means you need to compute the distance for computing the similarity. And if the notion of distance itself goes away while representing in a higher dimensions, then whatever distance measure techniques you deploy doesn't make sense, right? So that is what the curse of dimensionality is. So the objective is to reduce the number of dimensions before doing the analysis so that the meaning of the distance measure between the objects remains, right? It doesn't go away. The technique for dimensionality reduction with wavelet transforms we can use, that is a translation to another domain or a principal component analysis, which is called PCA, in which prime dimension is being identified. Dimensions are being identified out of all the dimensions, right? We call them principal components based on the eigenvalue and eigenvector representing the data sets. Or we can have a feature selection techniques where we try to select typically the relevant features, which we call them relevant features, or separate out the irrelevant features. These are the transforms from one domain to another that is being used. Wavelet transforms, principal component analysis, where we try to find the projection that captures the largest amount of variation in the data. So that becomes a principal component actually, right? And we find the eigenvectors of the covariance matrix. And these eigenvectors are going to define the new space out of all these dimensions, right? So whatever components we come across, that becomes a new space where the data points would be projected on, and then it will be less sparse. Less sparse means you have got a better meaning of distance and similarity. So principal component analysis steps can be discussed sometimes later. Attribute subset selection. Out of all the attributes, which are the relevant attributes, that is called feature selection. So we find irrelevant attributes, redundant attributes, remove them. There could be heuristic search in attribute selection. Out of D attributes, there are 2 to the power D possible attribute combination as a matter of permutant finding out the sets or groups, right? So it could be stepwise forward feature selection the best single attribute is picked first, the next best attribute condition to the first, and iteratively it progresses, right? Or it could be a stepwise attribute elimination, right? So repeatedly eliminate the worst attribute first, and the second, the next worst, and so on, right? Some approaches combine the attribute selection and elimination process, right? Like in decision tree, those who are from IT, they if ever they have made a decision tree to make a decision upon, so you know that out of all those attributes available, you have to find the most suitable, the best attribute to start with, to begin with, right? And then with each split in the tree, you need to decide the best attribute, right? So there are ways to do that, whether it is greedy based or it is entropy based or it is um, misclassification error based. So these are all quantitative measures that allows you to do that in order to decide upon the best attribute, right? Numerosity reduction can be taken up in order to reduce the data size.
Sir?
Hello?
Yes. Sir, how to find the best attribute for decision tree?
Best attribute for decision tree, as I told you, there are primarily three type of measures, quantitative measures that can be used. It could be entropy based, or it could be Gini index based. There is an index called Gini index, right? Or there is a misclassification error based approach where we compute, let's say, if we do it on A versus B, and if these are the two possible splits, right? And if we split on A, we compute the remaining classes. After the split, what is the Gini? Before the split, what is the Gini? Find out the difference, and that is called, we call it gain, or for the other combination as well. And wherever the gain is more, we do the we select that split. So there is a definite algorithmic way of doing it, right? It's not that, or you can choose it heuristically as well. If the model is simple, if the number of attributes are less, and you are a domain expert, so you know the meaning, right?
Okay.
When you are predicting rain, whether it will rain or not, so if you are a domain expert, you are not going to look at the temperature, or you're not going to look at the let's say the time of the day, right? So just observing the weather, or just observing the skyline, and the attributes related to that, whether it is cloudy or whether it is sunny. So if it is sunny, most probably it will not rain. If it is cloudy, most probably it can rain, right? Something like that. So it could be heuristic based if you are a domain experts, or better that the split on the attributes at each level, because decision tree would be multiple levels.
Yes.
Through होके leaf तक जाएगा, और हर level पे you have to make a decision that
on each node.
On each node, right? That which would be the best split, right?
Okay.
And the most simplest heuristic is that the more homogeneous class is after the split, right? The better is the split. Okay, it's something like if you have got, let's say, if you have got 10 students, and you split on boys and girls, like gender. Okay, so you have got 3 at one side and 7 at one side, and they are more homogeneous. All are boys here and all are girls here on gender basis. So this is split. When you do it for computing, for creating a male team and for selecting a female team. So that split is better. If you, anyhow, for selecting a male and female team, you start splitting with the height. Okay. So if height is less than 5 feet and height is more than 5 feet, so then after the split, at the leaf node, you will get a set of students who would be a mix of boys and girls at both the sides, right? So that group is not homogeneous, right? So typically you have chosen a wrong split attribute, heuristically, right? It could have been a better, because now if you choose any one of the group, you cannot make a male team selection or a female team selection, right? You can't do that. In the previous split, you can do that. So that's a simple heuristic, that if at the leaf node, the group is homogeneous, then the split is better, right? That its attribute selection is better, right? Otherwise, you can compute Gini or entropy, that is summation pi log pi, or like that. There are formulas for that. Okay. Okay. So I think it's time to summarize. Parametric data regression model and linear regression models could be used for further reducing the data. That is the making data fit into certain model, right? So once you get that model, you don't need, with the help of the model, you can further work upon that model, work upon that data, right? So if you know y is equal to mx plus c, so knowing x value, you can compute the y values, right? So whether it could be multiple regression or a simple regression. In histogram analysis, we divide data into buckets and store average sum for each bucket, average sum as a characteristics that represents each bucket. Clustering slightly, I have introduced that we partition data set into smaller groups. Each group having similar data. Across the group, you must have dissimilar data. That's a heuristic, right? Sampling is again a pre-processing task where in order to, these are all steps for dimensionality reduction, actually, all right? So sampling, those you have done must have seen the different type of sampling, whether it is a simple random sampling or it is a sampling, simple random sampling with replacement or without replacement. And then you have got, even in these two, have got certain problems of the data characteristics set like that. So you need a stratified sampling or a clustered sampling, where you collect sample from different stratas. So first partition the data and draw samples from each partition proportionately. So when the data is skewed, obviously this SRS with replacement, WR or WOR, both doesn't work, right? So this is a simple illustration of SRS, WR and WOR. Looking at the raw data, logically seems three grouping. You can find out the groupings after deploying the clustering techniques. Data compression, we are not going to talk much. Only thing is that you have already experienced compression of data files, whether it is a doc file you have compressed or PDF file, or the most compression you must have observed in your image files or video files. where so you know the compression ratio, and there's another term which is associated with the data compression algorithms, that is compression rate and compression ratio, which are important. So at what rate it is compressing the data, because if the data is in transmission mode, you have to monitor this rate, all right? And data compression ratio is important because it's half compressed or 1/10 compressed or whatever it is, right? So likewise, we have got data compression techniques. Data, the way we have transformed a problem definition in one domain to another domain, we can do certain data transformation by using methods like smoothing that removes the data noise, and techniques like aggregation, summarization. Data cube construction is a technique we adopt in data warehouses, where we compute data cubes, that is n-dimensional, and aggregates the data at different hierarchical levels, right? So it could be, let's say you are analyzing sales data. The data cubes might be computed at a local city level, then at local, further geographical, along the geographical hierarchy. You can have it at a city level, across the region or across the division and across the country and across the global one. Or you can have a product wise, right? So it could be home products, or it could be entertainments, electronic goods, right? And within the electronic goods, again, you can have concept hierarchies. So across the concept hierarchies, whether it is time, it could be hourly basis, or it could be daily sales, or monthly sales, weekly sales, bi-weekly sales, or so that's a concept hierarchy across the time notion, or concept hierarchy across the location, or concept hierarchy across the class or the product, right? So across each of these concept hierarchies, we can compute the aggregated values of the sales, right? So for this, we compute the data cubes, and normalization method, which are very prevalent for scaling data to fall within a smaller range, or within a similar range rather. If we are having observation from two sets of instruments in different scales, we can adopt either of these: min-max normalization, or Z-score normalization, decimal scaling, or discretization, right? So min-max is simple. Based on the maximum and minimum value, the current value is being adjusted to a new value. Z-score we compute on mean and standard deviation computation, and we get a new value for the current value. Based on the mean and standard deviation, we can compute, and accordingly we can do the decimal scaling. So these are all very simple. The only notion to understand here is that we are trying to process the data, trying to pre-process the data before actual analysis of the data, in order to improve upon the quality of the data. All right. So understanding the quality parameters of the data, and for each one of those quality parameters of the data, you have got different techniques to address with. Right. So I think we can stop here. So that's all about data quality. We talk a little bit, and data cleaning, data integration, data reduction, and transformation of data. All right. So some part of it I started with to summarize my talk, the explosion of data, the relevance of the data I tried to bring in, and the compute, the data-driven compute in which we are living with, some technologies that can be used for harnessing the potential of the data, and before actual analysis of the data, how to pre-process the data, all right, to prepare it for the analysis. So let's stop here because the time doesn't permit more. We can have any short queries we can address.
You are right. Actually, we have extended the time. Some of the participants are have to attend some meetings in their offices. Right. So I think we should stop here. Participants, in case you have any queries, you can go ahead with your queries. And those who had some meeting, they can leave. I got some calls actually.
Okay, okay.
So seems there is no doubt. Everything is very clear.
Yeah, that's great, because such a wonderful session. I mean, it's in cover in 2 hours. That is also a cumbersome task, but Anil sir has done it very well. Actually, this is a very, I mean, good activity that we have gone through. So again, I request every sir to please share the presentation with us so that it will be great, handy with us actually.
I'll be doing that. I'll be doing that. Okay. I'll be sending a mail.
You mail it to me. I will forward to all the participants. So right. Even the morning sessions PPT, I'll be getting it by evening. So I will mail both the PPTs by after I get these PPTs.
Okay, thank you. Thank you for giving me a patient hearing, and thanks a lot.
Thank you. Thank you very much, Mr. Singh. Thank you very much.
Thank you, Prof. Sir.
Thanks, Ryan.
All right. You can leave this meeting. So participants, so tomorrow we'll meet at 10 o'clock for the next session. I hope you are gaining